right, welcome in, family. I have something special for you today. It's your man. I am going to go through some of this random nonsense that I've been working on. That it actually involves Csound, if you can believe it. Recently, I was informed that the legend John Fitch, unfortunately, has ascended to the higher realms, and that's really sad because he was a legend, for us in the Csound community. But what I wanted to do was make a quick video showing kind of what I've been up to lately, what I've been working on, doing a lot of vibe coding. And this is the era of AI, of course, but I've been using a lot more chops. I've been trying to learn C++ more lately, and been using a little bit of the Olama, just the offline version of the AI models to not screw up the planet. Because we have a lot of that to worry about. We're not using up all the fresh water and everything like that. But I've got 8 Csound demos to show you in this video. I've got a couple games I want to show you that I've been working on, and a couple visualizers, 8 of these. So hopefully I'll make through it pretty quick. But it's great to be with you. So let's jump into it, guys. Like, I want to show you guys and gals and she's and gays and theys and everybody else, so everybody can get down in the Csound. What I want to kind of do before I start showing this is get into the philosophy of it just slightly, where what's really amazing about Csound, and I think John Fitch's legacy a little bit, is that once you understand kind of the plumbing of Csound, it's got this OPDS structure, and it's got this pooled memory and these other things, like this plumbing. Let's call it plumbing. Once you understand that, a lot of the Csound algorithms work sort of on the sample level when it's processing audio. So it's amazingly elegant how portable that is if you can get your mind around sort of that Csound specific plumbing. So that's what this is. This essentially, every one of these projects leverages a open source wrapper called, and I'll show it on the screen, called openFrameworks. So that's what this is. This is every single one of these I've been working on. It's an open source C++ toolkit for creative coding, and since time immemorial, perhaps Csound has been leveraged as like kind of an engine. And in the early 2000s, we had sort of the Tickle TK and the Wish shell, and we had Csound AV, and we had Mac Csound, and we had all these different ways to communicate. And I mean, even now, all kinds of people are using Python and other interfaces for the graphic user experience. And so for me, I wanted to try this with openFrameworks because I love all the stuff that's in here. It's got OSC, it's got all these things. But crucially, it for me strikes the balance of performance over flashiness, over ease of use. Where I don't think you necessarily, or I might not necessarily get that in Python, because what I'm trying to do essentially is in some ways like use full duplex audio, which is input and output at the same time. I'm trying to leverage a lot of shaders and like visual things to augment live performance. So for me, it's really important that stuff's very computationally efficient, works live, works in real time. These are all very computationally intensive things. And for me specifically, why I chose openFrameworks for this stuff is I'm trying to push as many calculations to the graphics processing unit over the CPU as possible. Now, one of the things I learned in doing this is that there's situations where you can be too overzealous in trying to push stuff to the GPU, where it's more computationally intensive to push stuff to the GPU and get it back than it is to just run it through the CPU. So, whoops. But anyway, so here we go. BB cut. This is the legendary thing from Csound. You can see kind of a basic user interface on it. But what this does is it reinterprets Csound's BB cuts opcodes, and then I sort of added just a resonant low-pass filter. So, of course, when you're talking about BB cuts, really it's important to think through jungle music. So let's use some jungle music. I'll use my mixed black rainbow. And I think it's at 166 BPM, so we got to calculate that in cycles per second. In our case, this would be 2.7 or so. We'll set that up, 0.7. It looks like it is coming through a little bit, but it's got a filter, of course. And so the volume is here, and yeah, we have our little BP cut thing. So we can change the subdivisions. We can change like the length of the audio and visual cues, the bar beats, all the stuff that you have kind of within the BB cuts, Csound implementation. It really just takes the source code and kind of wraps it. It does different plumbing, specific to openFrameworks. Yeah, here you go. So you got a nice little resonant low-pass filter here. You can change your resonance, and you can kind of go up and down and clipping and so on. And it's kind of fun to try this and mess around with it. But here you go, BB cuts. We can do different subdivisions, you know, and it has kind of a real-time display. This one's not really using the graphics interface at all. But a lot of fun, you know, a lot of fun. And one of the things I did with this is, you know, it's so fun to screw around with this kind of stuff. I like to make recording, the ability to record the output of these things. This one I don't think has it, but I might add it pretty soon because I have it on C. Here you go, BB cuts from the Csound implementation. So that's the first one. This one, BPM. Okay, this is a real basic one. I made a lot of tools that were real simple, but this one just tap. You just tap the tempo. You know, sometimes you need to do this just to, you know, if you want to get BPS or whatever. And it's looking at the space bar. You just press the space bar and, you know, it counts like, you know, however many samples you want. You can configure it in the source, but reset it and so on. Just a nice little tool. A lot of fun to use. The next Csound thing here, which is a lot of fun, D-Mix. So this is Dan Barry's thing from the DAFX 2004. Something that had a big effect on me, of course, in my training and experience. But really novel concept of this address algorithm. So essentially the way this works is you load a stereo file, and you essentially split the stereo field into a bunch of slices. And what this does is it wraps the interface for that opcode and gives you kind of the width of a different slice and how many slices and the different window types, and you can change the FFT parameters and so on. So I just made it to kind of try, you know, for fun. So you can see this is the clip here. We've got some audio coming through. You can see on the right we've got a little spectrogram, and the way you interact with this is that you drag your mouse on the, you know, within the stereo field, and it's trying to localize on where it thinks the hotspots are, which is the colors on the left side of the screen. You can kind of see that it tries to get a little bit of heat map. It's not perfect, but this is maybe not good program material because you can kind of tell it kind of acts the most. You hear it the most kind of in the middle, which you might expect for dance music. This happens to be a particularly old funk record or whatever. But yeah, a lot of fun. So, you know, back in the days when I first discovered this, and before it was even in Csound, it was just so computationally intensive. People said they'd never be able to do this in real time. So I didn't forget. Still working on it. But here it is. Here's just a rudimentary way to implement it. It's just based on the Csound source code, and what an amazing pedagogical legacy, you know, is Csound. I think if you're watching this and you happen to know about Csound, it's probably not a surprise to you. But this one you can see has the ability to record output. So if you do find an audio file, perhaps like an old jazz record or something, and you want to just get the vocals out, lets you do that. So, you know, kind of what compels me to share all this stuff with the world is I've started using it for my music production lately. You know, I've gotten to the point where the chops are there with Csound and with C++ and openFrameworks that I'm making stuff I actually use, and start to show you about that in a minute here. This one is a wrapper of the VCO2 opcode. So you see this was the D-Mix. We had this one, so this talks about Dan Barry's source. I was supposed to show it, I didn't, but here's the VCO2. Uses the same input. So one of the things I had to kind of make a decision about is, you know, the Csound has the distinction between audio and control rates and so on. The C++ stuff doesn't really make such a distinction. So what I'm doing is, design-wise, I'm making this as a testable DSP core, and then using kind of the standard library Atomic to go between the GUI, the graphic user interface, and the engine parameters. So it's kind of a proxy for the K rate a little bit. It's pretty computationally efficient, but it's perhaps not ideal. But you know, we do what we do out here. You know, these streets is mean or whatever. You know, you got to kind of make do. But nonetheless, here we got some piano roll kind of view. You can see we got a little synthesizer here, and you know, if I wanted to make like a little low pass filter or something, have some resonance to it. The resonance going here. We got a little pattern. We can make a little pattern, you know, different here. So these are notes. You can kind of make the notes, and then you right click on it to make a tie. And then these are like velocity underneath. So it's modeled on the Reason matrix sequencer, you know, kind of thing. So you can kind of pick the BPM and you know, the resolution of the subdivisions and how many steps you have and so on. A lot of fun to use. And then it has a little bit of an FM thing, ring modulator, noise, color, just some stuff for the oscillators to play around with. And of course, you know, you can change it around. We can make the different wave shapes. You can make them both sawtooth waves or square waves. So there's a little legend here because I sometimes forget, you know, what I put in here. But a lot of fun. You know, a lot of fun to mess around with, guys, like gals. in days. This is a lot of fun, and perhaps useful to somebody. So here it is. Get some Csound. VCO2 plus resonant low pass filter. This one doesn't have the nice interface the other one had, but it's the same idea. With this low pass filter thing, or I should say state variable filter, because I added the notch and the other things too. Not a biquad. Didn't need to go to the level of computing coefficients and so on. Just just a nice little state variable filter, similar to like those UDOs that people have, user defined opcodes and so on, and Csound. Yeah, what an amazing thing. The next one, devlist. This one, I'm going to show this in the command line. This is just a real simple program I made to kind of help just display output of the device list. And this is kind of the reason it's in the Csound folder is it's within the spirit of Csound. It's Csound historically a lot of command line interface, and you see that here. We have our little command line interface. Shows me the different APIs. The WAS API at Microsoft. We got ASIO. We've got Direct Show. I don't know. I tend to like Direct Show. To me, this isn't so much of a performance issue. It's more of a what's going to be compatible. So like when I start to think about distributing this type of software and giving it to you all, I got to start thinking about what makes sense in terms of packaging up a static library, and I probably have to come up with a little preferences dialog or something where you can queries the system and you can pick and whatever. But look, I'm not I'm not making that level of commercialization yet, but well, we'll get there. Okay, the next one, a lot of fun with this one. Here we go. Reverb SC, Sean Costello Reverb. Okay, so let's look at the Csound for this one. This was one of my favorite sounding reverbs. Been using Csound for a long time, and it's this 8 delay line stereo FDN reverb finite delay network by Sean Costello. Originally, it existed as a UDO in Csound for a long time, and somebody implemented it, perhaps, or it looks like Istvan Varga did it in 2005, made it as an opcode. Really nice sounding thing. But one of the things that I wanted to do with this openFrameworks thing is, you can see, is in addition to mapping the parameters and taking the basic elements of the DSP, I wanted to map it to kind of a pre and post spectrum. So the top is a pre-spectrum, the bottom is the post-spectrum, or the reverb, so you can kind of see the effect of it. And then the bottom is a time domain representation of the output waveform, sort of instantaneous time domain. And then we've got, of course, our Lisa Zhu plot down here. So let's just demonstrate this. I'll use this as basic program material. You've got, we got some events right here. Okay, so what you see here is the input kind of not going to change. This is just from the audio file. So what's very interesting is I put a pre and a post filter in here. So like, for example, it's bypass now, but if I wanted it to be a low pass, and then, I made this as, 100% wet. So you're only listening to the output wet. You see what happens to the spectrum? This is a fantastic tool to illustrate the effect of it, in the sense that we call it a smearing, or what have you. So you can see kind of like when we change the cutoff of the filter, you actually can like see it in the spectrogram, in the heat map. So you can see the difference between pre and post. And we have our a lot of fun. Change the dry wet mix. We can record the output. It's got an output record, and then it's got a post filter. Wanted that. We also have log versus linear frequency if you care about formants and speech science. We can do that. But in this case, it's just fun to see. You still kind of see it. Also made it so I can configure the range. So you can make it be like down to 20. Now, you do have some DC bias stuff in here. You get real low, but you can link around with it. And of course, you can stay in those settings with the interface. Real nice stuff is openFrameworks. As you look at it, you turn it off and you see the audio file. You see that? You get the trailing off, that reverb. Fun stuff. Fun. But back to Csound, Okay, so that was Reverb SC. Couple other things. So there was a program a long time ago. I want to make sure I'm getting this right. Let's see if I can find it. It's a program called SoundPeak, and I want to make sure I'm giving the right attributions, because of course there's plenty of credit to go around when we talk about stuff like this. SoundPeak, Princeton University, was by Ji Wang, so the man who is responsible, I think, for the Chuck programming language, Perry Cook, Ananya Misra, and George Tzanikis. with this plugin thing. 2003 to present. So this is SoundPeak. Okay, so this is kind of what it looks like. They've got the SoundPeak waterfall kind of display, and what I thought would be real fun was to take it's you can get the source for it, of course. What I thought would be fun was to take this and try to make it. I was having problems with all the dependencies on Windows, which, as you can see, I'm on Windows. Just a nightmare with these different like deprecated versions of libraries and dependencies and stuff. I'm like, you know what? Forget it. Let me just put this in openFrameworks, use the processing, and get that rolling. So that's what this is. Now it's actually kind of a direct port, so it needs to have command line input. Actually, I don't know if there's a way I can do a dialog. I should probably put it in there, but I did keep the license information and the authorship present because you got to be good stewards out here. We're trying to learn, but we're also got to give credit where credit's due. Okay, so this one you can see it's running. It doesn't have the audio display. I can show you that. So let's just go into SoundPeak, and we will just make it run it as a binary, and then we'll use just on the desktop. Let's see, all hands pride or something. Let's kind of see it. It's just a kind of a basic port, and so you can see one of the things I got to work on here is the scaling, but it does have the ability to like kind of modify it. So it can look like the original, SoundPeak. And you can kind of go up and down, and you can freeze it, you can make it full screen and everything. Like, just I try to make it like basically the equivalent to it looks like that freezes the doesn't the display capture doesn't work right. It looks like but you get the idea. Like it's basically just SoundPeak implemented in openFrameworks. Got a couple things I got to figure out, but I felt like it was okay to show it, just to have fun with it. But just kind of a nice little tool here. One of the things that'd be interesting is like the log factor. Like, how do you perceive this? Because you think about how would you use this, right? How do you want to use this in practice? Well, it's probably useful for perhaps sniffing out artifacts, getting a rough idea of a mix, between DC and Nyquist, which is where we operate our digital audio and so on. But there's some nice things. You can have it. I made it so you can draw the playhead. So like this is a waterfall, but like where are we right now in time? And you can see it kind of within the context of the Lissajous and the time domain representation. One of the things I want to kind of figure out is like making it so that the waterfall display isn't necessarily affected by the gain, because you kind of want the waterfall display to be scaled differently than the time domain. But look, I gotta figure this out, mate. It's actually a pretty complex program. Is SoundPeak. So this was just my little rough and dirty way to kind of implement what they did. And I think part of it is I'm not fully understanding everything they're doing, but that's okay because these people are university professors. I got a different I got a different job, and I do this for fun, So this is fun to do this. But Lissajous, you can kind of change the scale of that. You can change where you're looking at it from. You can kind of rotate it, which is a lot of fun. You can freeze it, so you can kind of look around. Dude, look, it's just like it's frozen. And I made it so I can change the input device. With the G1 Prairie Cook an Anya program, you got to kind of specify that in the command line. I can do that with this. I added that in where it parses the command line arguments, but if I'm going to put a GUI in here, I might as well just at some point add in a display and stuff like that. But what I was trying to do was like preserve the original authorship, so I didn't have to put my name on it and I made all these changes and all this stuff, whatever. Like, I just think it's cool. I think it's a cool visual. Realistically, what I might think this would be cool for is like a live input, as kind of like a visualizer display. Like map this onto something live for your live performance. I think that'd be kind of cool. Okay, so that's SoundPeak. The last one in my Csound folder, which is kind of not really Csound, but it relates to Csound a little bit. I'm calling it WaveForge. WaveForge. So what this one does is, there's myriad 2-track editor programs out there, meaning that stereo audio or what have you. You can see on my desktop even I got Audacity, I got Wavesaur, great programs. But what this one does is there was a feature in a program a long time ago called Bias Peak, which many of you may know, and I try to make it look like that in terms of its colors. But what you could do is this idea of nonlinear editing or non-destructive editing and hard disk recording. And so what does that mean? So okay, so this shows you the time domain representation. You got the two tracks, and I'm kind of drawing it as rectangles, but of course, when we deal with serious audio, you want to be able to see to the sample level, of course. So naturally, that's what we're doing here. And so what you want to do, of course, is like pick, right away, right before the sample index, where it starts to hit. You know what I mean? Like, and you just, here we go. Ooh, let's go. Okay, so we've got our real time nonsense here, right? Okay, so what this program is meant to do is you press M to create a marker, just like you could in Bias Peak. And what this does is it allows you to kind of mark regions non-destructively. So it doesn't write anything to audio file or anything like that. But what you do is you kind of like, you search around and, maybe I can make this interface a little bit different. I made it like recenter and stuff, but is it like, I don't know, is this a good example? Yeah, okay, so we'll just do that. Okay, so we'll put a marker here. I'm just trying to demonstrate it. We might put a little here, and I'm not going to be that precise with these, just to show you the effect of it. Okay, so we're going to put markers here, marker here, marker here, marker here. We'll do a couple here, like we'll just do 2 here, and then I'll put 1 at the very end. Okay, so you now see there's a bunch of markers in this list here. We've got our audio file, and there's nothing in the transport window that really affects the markers. Other than just trying to find it. Now, I did add like a normalize, and a other thing. But what's really key about this program is that it allows you to bounce these markers. So one of the things I don't see it a lot in modern software. Maybe it's in some of those expensive DAW programs, digital audio workstation. But for me, what I need is something lightweight, fast, that I can just take markers, right? So like, let's say I take 5, 5, 6, 3, 8, 7, whatever. So, okay, so then we'll do that. Okay, so what this does, and look how fast this is it'll sequence an output file that's between the markers. So it'll start from M1, and it'll kind of get all that audio buffer data and make it into a new file. So it's kind of important to be sample accurate. You see how fast that was? Already done, already complete. See that? That's why I need it to be in C++, mate, because ooh, let's go. Fast, fast, fast. I need it. I need it coming fast. Okay, so WaveForge. Okay, so then what you see here, and I'll show it to you in a different program so you can kind of get an idea of it. Okay, so this was our bounce. This is our regions rather, and we did our little bounce. Let's use Wavesaur just to show you what it looks like. Okay, so it's in the binary folder. It's kind of a big file, but you can see, look what happened. So it's but you see that? It gets all the stuff. See that? Ooh, see that? Then it fades out. That's gonna fade out. Then we're gonna go. Okay, so that goes nothing. So this one's really useful. I actually use this. I'm starting to use this all the time when I'm making, tracks and stems and edits and stuff. Because, what's really cool about this is like for example, one of the things I didn't know I would think this would be useful for, but you might think it's useful, is you can basically like press record on whatever and start zapping away with your Nord modular or your drum machine or your 303 or whatever synthesizer you got on hand. Start jamming away. And you can have like one shots and then make it into a composite file or output them as separate files, because there's nothing that tells you can you don't have to bounce necessarily, one thing, you know what I mean? Like you can bounce different things in different ways. So lots of fun, right? Lots and lots of fun to bounce different stuff in different ways, like your one shots, or like it helps you really easily cut up like a long audio file and like make a composite out of it. Or let's say you have a few different beats that you want to combine or splice, or even the output of like the BB cuts thing. You know what I mean? Like let's say you have your BB cuts and like, oh, it's 90% good, but I want to change this one little thing about it. Okay, just use the WaveForge thing. So that's my showcase on Csound. Good stuff, everybody. Thanks for being here for Csound. I want to show kind of the rest of them. Let's see how we're doing time. We're doing 24 minutes. Okay, so let's keep it rolling long form. I'm going to go through the games. These are pretty quick hits. 2 games. So the first one is I'm calling it Prismfall. And it's basically meant to be like a colorblind friendly columns. I happen to be very colorblind. That's why I do sound. But I thought it'd be fun. And the idea I wanted to work on here was, of course, the 3 design principles for digital, which are in other words, when I say design principles, I mean things that make you addicted to technology. And this comes from Meta companies pointing the strongest computers that humanity has made at the human brain. And what they found was if you did three things in software, people will be addicted. Those three things are incremental progress, unexpected gratification, and a goal that's just out of reach. Those three things together somehow, if you can implement those in a nice design, makes people really want to play your stuff. So I tried to do that here. You can see there's like different game modes, endless sprint gauntlet, whatever. I have different characters, so they have just like different bonuses when there's gift tiles and there's rumbling and explosions. This is the unexpected gratification thing. And then, of course, you can have difficulty, which, is like a goal that's just out of reach could be, the different levels of the characters and like, implementing like the different styles and different methods and whatever. So and it keeps persistence. That's the other thing is, it gives you more difficulty, but also more reward. So that's fun. So basically, what does it do? It's like columns, mate. So you just you play the game, you move it around, you can flip them, and then the combinations are like columns. But why it's colorblind friendly is that it's using the shapes. So like even though I can't really see the colors, and frankly these are not great colors for my colorblindness, but they're okay. It's lets you do the thing. So it's like it's using shapes, kind of like columns in terms of its scoring. Like the yellow stuff. I mean, maybe it's a little bit hard for me to see, but that's the vision anyway for this as a colorblind accessible game. Because accessibility is for everyone, right? Like, even if you don't think so, it is. That's a good thing. But yeah, columns for colorblind. Lots of fun, and it's just the basic thing, and you can see kind of screwing it up, but whatever. So you get the idea. Lots of fun. So we have our game. We call them Prismfall. Got some bloom effects. Got toroids. Different things. These are all the different shapes, but representing the gems. I might make these couple of these colors a little bit more contrasted, but they're pleasing to look at anyway. Yeah, lots of fun. Kind of a mobile. It could be a mobile game at some point. I don't know. But yeah, here we go. And then the classic. This is for the real heads out there. The classic game for those of you who are either in Massachusetts or Eau Claire or South Bend, Indiana or Minneapolis. Zonk, the game Zonk, the classic, the legendary thing. So what is Zonk? It's a dice game where you throw. Depends on where you live, but 5 or 6 dice, and there's different scoring and so on. And I have a soft spot for Zonk because it's a lot of fun. I had a lot of fun with it in my youth. Playing in-person games. A lot of times we play video games, and those give you a lot of gratification. But there's nothing that beats being in person. It's like medicine, right? So what is this? Zonk. It's an implementation of Zonk, but what's new about it? You can see, look where we are, right? We're using the motion picture HDR format to be in a 3-dimensional space. So this happens to be in some grungy like garage or something, just for fun. I have a bunch of them, so this is all from the HDRI shaders, like free shaders. So here's a pure sky, another sky. We've got our little gym, CrossFit gym. God, this is my favorite one, like a back room that's all dirty and full of junk. That's where you want to play Zonk. That's where I want to play Zonk right now. But then we got some nicer ones like a photo studio, like nice little thing, and you can kind of zoom in, zoom out, whatever. You move around. So it's Zonk. It's a little bit Zonk. It doesn't have online right now. Maybe that's in scope, maybe not, but we could be our nice little idyllic California villa on the mountains or whatever, or Arizona or wherever this. But 3-dimensional, the HDR format, lots of fun to show that. Pretty easy to implement too, actually. Okay, so we've got different things. We also got different materials for the dice to make them look different, and we have a light source, point light source. But yeah, so here we got some dice, and so on. Little dice thing, different kind of materials and contrast and stuff for not exactly accessibility, but to some extent. Okay, so let's say we're gonna call our names, and then this is the thing about Zonk too, is calling people by their name. So we'll say Snarf, and we'll say Ball or Foobar or whatever. Yeah, Foo and Bar. Let's do that. Let's do Foobar because that's classic computer stuff. Okay, so it's got an automatic rules engine. That was a design decision I made. Maybe not the best idea. But I feel like it's because it's like a party game. It's meant to be a little bit strategic, but not like over the top strategic. So what is it? What are the rules basically? Well, you roll one, so 100 points, five's 50, three of a kind's 100 times the number, and three ones is 1,000. So you can see here we've got 1, 1, 5, 3, 4. These three are scoring, and there's a rules engine, so it enforces that. So we keep rolling. Oh, we get a zonk because we didn't get any scoring dice. So then it's Bar's turn. Every 100 point or every 1,000 points, we get a bonus or hit. Now we can see every game it does create a magic number, which is random, and that was a pretty rare occurrence. You just saw a magic number. Everybody gets scored. Cool. So this would also be scoring as a 5. So we're going, we zonk. So we don't get any points, but this is the game. So the basically the decision loop is you roll the dice, you choose to bank your score or continue. So in this case, if we banked, we'd have a turn score of 100. We want to either get 10,000 exactly, or you go overtime greater than or equal to 13,000. So I went through and I implemented all this stuff. So here we go, 500. We'll bank 500, and that's how the game goes. Every 1,000 points, you get a little special reward, whatever that is. Everybody's a little different. Sometimes it's a breath of fresh air. Sometimes it's I don't know, whatever it is. But you guys pick a bite of a sandwich. Who knows? But it's Zonk. It's a lot of fun. Zonk. But yeah, so you can party game, a lot of fun, dice game. So what's next for this? Here's 1,000 points. Let's go. 1,000 points. 1,500 for Foo. Lara's got to catch up. You can see table stabilization. One of the things I got as feedback for this was that the dice need to be further apart. So I did add some like throw force, gravity sort of like things to help with that. So you can kind of make it like I wanted to make it so you could feel like you simulate it, because next steps for me on this would be like online, perhaps making it so that there's accelerometer inputs. That'd be kind of fun. So you can actually like roll the dice. That's super fun. Have like a little haptic interface. But this is the core element of it. The design decision I made, very similar to a lot of the synth stuff, where I make a testable core and then put the graphic stuff on top. That seemed to be a really good design decision in a lot of cases, especially for the audio synthesis stuff, because a lot of stuff like that just ends up hard to deal with. But yeah, here you go, Zonk. Lots of fun, right? So there's a couple of games that we want to show. Last up, we're going to finish strong. We have some visualizers. So what is the purpose of this? What's the point? Well, as I said earlier in the video, I really like the idea of live performance. These days, I'm doing a lot of DJing because for me, that's like arranging. It's like real-time arranging. So instead of playing an instrument, I'm sort of feeling like a conductor, and I take all this program material and mash it together. In a way, I see it as like blending cultural influences, and I make something that's like queer body music, basically, if you will, for dancing. I've described this to others as dance music speaks to a really primal part of our humanity. It's us stomping around the fire, hitting dinosaur bones on the ground, tongue in cheek. But what I love about dance music and techno and house music is that it exists between this tension of primacy and innovation. Primacy meaning hitting the dinosaur bones on the ground, and innovation insofar as like this very technologically advanced, high technology. What does that mean? Well, we're using this digital audio playback stuff, and we're mixing sound in an analog way. And a lot of times we'll have visualizers on the place. And so this is an attempt to create more of a sensory immersive experience when people come to see me do visuals, or do techno rather, or house music. So the first one here, we got just a basic visual synth. So it's meant to be kind of a parallax scrolling background. It does have audio input, but in prepping for this meeting, I didn't want to sit and doink around with all the input device selection and stuff. So that's why it's not as colorful and not moving around as much, but it's just kind of a basic parallax thing, kind of getting ready for it. But generative synthesis. Here you go. Look at that. Using some shaders, so abstracting a lot of calculations to GPU. This one I might actually use in real life. I'm calling it thermal cam. Basically, it's supposed to look like the Predator's heat vision, from the 80s movie, The Predator, right? Like that's what this is meant to be. So you can kind of see it's got a separate camera. It's looking at it. You can see kind of this heat shimmer effect. But notice there's no interface to it. It's on or it's off. Very simple. And it's actually a very, very simple program, if I can show that. And I'm trying, with this one, I think I have another video on YouTube where I made the source code available. And I'll make the source code available for all of these. It's just kind of a lot of effort. But I have no problems, sharing it. So reach out to me, hit me up, if you want it sooner. But so it's not the Predator thermal, it's the thermal cam, which I want to release at version 1. But it's just these three things, and essentially what it is it just loads the heavy lifting happens in the shader. So it's a GL shader basically, and so you can see I really love this idea. There's a frag and a vert. So what this is this is the calculations that are actually happening on the GPU. You can see there's a main function, and basically just doing distorted and what it's doing is it converts it to grayscale to find the heat. So it's black and white, and then it kind of modulates it based on like segmenting it in terms of its colors, and it's a proxy for heat. So I thought it was a fun idea to kind of come up with this and make it work. And then the other thing is it's got a sine cosine calculation here for the heat shimmer effect. And that's really efficient on the GPU, which I love. So this thing works great in real time. Depending on the camera, if you got a nice USB camera that can do 60 frames, you can have it look really nice. And it's not limited by the program. Fun. So that's the thermal cam. I want to show maybe related to that is I'm calling it Predator Thermal. This is almost like version 2, but it's the same essential logic to the program. But what this one does differently is it's got a graphic interface. So you think about being at the nightclub and you're projecting on the screen, or let's say you're using a projector and you've kind of got this 2-monitor setup. This is meant so that you can kind of put this on a different monitor, and then you can doink around with it with the GUI. You know what I mean? So this one actually has a time control. You see that? It's kind of like I can make it go, kind of match the music. This one is not audio reactive. I don't know if I said that, but not audio reactive is this one. But at the same time, you can make it kind of go at a different rate. So perhaps you want to do like a multiple or a lower end multiple, or you can turn it off, but you're just not have it move at all. But then you also can have it where it's like heat specific shimmer. And I'm still working on this effect where the shimmer is intended to look more or be more intense where the areas are hotter. So it's essentially taking instead of doing this calculation on the entire buffer, it's doing the GPU. It's pushing that to the GPU and doing it per pixel on the GPU instead of the whole frame buffer. So it's much more efficient that way. And of course, GPU is designed for that, right? I mean, it's designed for calculations involving per pixel enumerations, colors, and modes and so on. The other thing that's nice about this version is I actually made it so I can change the resolution. So look at this, so I can make it like smaller, just to like be more efficient. And what I didn't think, and I got to figure this out, it changes the magnitude of the heat shimmer. And I think because I'm using scalar values, it changes like the size of like the bulbs or whatever on the heat shimmer, which I think is cool. Didn't anticipate it. Happy accidents, perhaps. But it can go all the way down, to 640 by 360, and it's treating the whole pix buffer like that, so it's not actually reconfiguring the camera. It's just kind of taking the camera's input and mapping it in a perhaps less precise, less resolution. I don't know how you want to say it. So here's a 1280 by 720 at 60 frames. Cool, right? Like, looks cool. Like, I don't know. I think this looks cool. Okay, so I get excited. Okay, the other one I wanted to show you that's super fun is the Hypno engine. This one is for like techno, right? So this one's super fun. It's the same idea. You've got kind of a separate GUI or graphic user interface, and then you've got the render window. So what's different about this one? Well, look on here. It's got an automatic timer, and I tried to make it go real smooth when I want to jump. So like I can make it, kind of jump to the next thing. So if I put some hotkeys to it, and I'm not sure, I can't remember what they all are, but that's look, design decision. Maybe I should have another window that pops up and shows them all. They're in this window, but I gotta just look at it. It's spacebar. Okay, so then I can have it morph. It's intended to morph real slow. See that? So no audio to it, not audio reactive either, but it's just meant to kind of like the idea is you'd want to sync it with your program material, so you can make it go real slow too. Like I put it at 60 at the low end in case you didn't want to move, but you do kind of want some motion here just to give people the sense of progression. And then so it's just, I'll show you the different patterns. So this is the scan lines pattern going to the spiral. And there's a pre and post. So there's actually this is all happening on the GPU shader. So I can see my CPU, it's like 1% right now. It's all on the GPU, but pre and post. So you have like you can see there's like a filter thing I have on here for like the bloom, and you see them all here: the warp, the intensity, the tint hue, and so on. I'm so used to like looking at graphics. Being colorblind, it helps me to like visualize or parameterize, let's say, the graphic elements that we're interested in. So, and it is random when I'm pressing spacebar, so I might just do direct index just to go. But it should just be, yeah, random. Here's the checkerboard one coming in. So it's like checkered hallway, and um, trying to give you like the perception of depth. And my vision for this would be like perhaps you want to disable the post processing, you see, so it's a lot crisper. But then you could do like a chroma key or something on black and white. And so then you could have this actually map a projection map or something to another, visual thing. It'd be super fun. Have it look real cool. Okay, so here we're going back to the scan lines, morphing back to the spiral. You saw the zigzag star. We got to show you contour and vortex. And if you do nothing, it will change automatically like this. So I'm just forcing it. So this is the contour, which I love this. I think this would be so fun for techno, like at a show, is to look at this. The other thing is like you can change the pulse amount too. So I can make it just kind of like not pulse, if you wanted to do that. And you can see how I can do that all throughout. And then of course you can see this warp. Check this out. So there's a force perspective shift that kind of moves around. I can make that. So it's going to kind of move around. So it just gives you the motion. Now the problem with this, of course, if uh, it gets pretty close, if not over the line, of needing to have the epilepsy warning, like photosensitive warning that you see on sometimes on like video games and stuff. This one's pretty close to needing that. You start to trigger some regulatory stuff here. Not on purpose, of course, just, that's how it goes. We want to be sensitive to our colleagues and friends that are differently abled. Okay, so here is the scan line. We now one more, I think, vortex. We want to show you the vortex. I think I can go explicit index, can I? Yeah. Here's the vortex. So this is vortex. And you can see you disable the post processing. You see the post processing. So you can see like you can change the bloom amount. And I can make it have kind of more trail stuff. Not as apparent on the vortex one. But a lot of fun. You see, and I can make it kind of tint a little bit different. So this would be super fun. Like if I map this to like a parameter set or an OSC thing, and gave somebody like a little box of knobs or something, and said, hey, can you do this? Can you help out? With doing this gig? Can you modulate this and make it look real cool? I think this one is a close one to being commercially ready. To kind of like put in front of people. Some of the ones maybe need a little bit more work, but it's fun that I have this like sort of hue, saturation, value kind of color thing in here, because then you could kind of like you can actually like kind of perform this alongside a DJ, and if you project this on the wall, or let's say you projection map it on like an object or something, you don't have to use the post processing either. You could, depends on how. Really, that's a concession to like lower quality projectors, is why I put that in there. Because sometimes like it seems like the lower quality of the projector you got, the kind of more it smears, So that's kind of for that, but this would probably still look good though. And the energy level is just meant, this is just silliness. I was going to add some audio reactivity or something. So these are the bands that it would be audio reactive, but they're just, it's nothing. It's not actually anything. It's actually a little bit of a proxy for the GPU clock. As a matter of fact, like that's really what it is, but is it meaningful? Not really. Like the levels and the axes aren't really meaningful, but it's meant to be a proxy for if I was going to make it audio reactive, I'd segment it into the frequency response range into this many subdivisions and then operate on that. So the hypnosis engine supposed to make you hypnotized. Ooh, how's it going? How's it doing? Hypnotized. Okay, a couple more left. Synthedelia. This will be a fun one. This one is one of my favorites. It's like it was one of the first things I did on the shader math. But what's cool about it is it's just leveraging primitives. So these are actually like it's a big spiral and it's a triangle cone mesh in there. And I should make it so I can dynamically change the density of it. But sometimes you can make it be real dense and like not as dense. But it's if you think about it, it's kind of meant as like a projection color thing, that I'd want to add on something else. So that's this projection color map, Synthedelia. nice. It's a calming for me. It's calming. It's soothing background. You know, it's just like a little lava lamp kind of thing. So that was fun to try. It was one of the first experiments I did putting stuff on the GPU. We looked at VizSense psychedelic AV. This one I don't know if it'll work, but this idea was just an audio reactive thing. There is a video on my YouTube channel where I use it, but you could see that the graphic interface is within the main render window. And then this was the first time I kind of understood how I could abstract that to like a separate window. So the GUI being separate windows, and kind of it's when you deal with pure C++ or even openFrameworks, it's like you're sharing pointers, and you have to have a pointer to the main uh, place where the app is, and you got to kind of index memory. You got to be real careful with that stuff. But that's a lot of fun. So I showed you VizSynth. I showed you Synth. Okay, so awesome. Thank you for being along with me on this journey. We went through some Csound, went through a couple games, went through a lot of stuff. What I wanted to show you real quick, if you want to support me and support what I'm doing and what I'm about, of course, download Csound, right? Like, I think Csound's great. You might learn something, but follow me on, what is this called? SoundCloud. Follow me on SoundCloud. Okay, here's my SoundCloud URL. Follow me on Mixcloud. You can see this is my Mixcloud URL here. Follow me here. You can stay up to date with my latest mixing and nonsense. You could follow me on YouTube. See here on YouTube, you can see this is where I kind of did. So this is the thermal one where I'm actually mixing. And then I think one of these, I think maybe Crystallic. Yeah, this was the psychedelic AV one. I'll turn the audio off on this one, but that's kind of what the audio reactivity looks like here. But yeah, give me a follow, give me a subscribe if you think it's worth catching up. That's where this video will be. You can see the source code. I'm going to start putting the source code in the video description. You see a nice little paste bin if you want to try the psychedelic AV one. So you can see very similar to Csound. It's a setup function and other things. If you understand kind of Csound and computer programming and languages in general, like this won't be very hard for you to understand. Part of the reason I'm using it. And then finally, if you want to check me out on Instagram, my Instagram is this. You can check me out here at dj.dav.minneapolis. And so I have this. And you can see even here, in Marquis Who's Who in America lately. So catch up with me, get at me, stay weird out there. Thank you for being with me on this journey. See you in the next video.